Okay, so differentiation, pure 4, and the spec says we've got a differentiation of simple functions defined implicitly or parametrically, and formation of simple differential equations. So this is when we're using the rates of change, and then what we're going to do is when we do the integration chapter, we're going to come back to more rates of change. This is like an introduction to rates of change question, the simpler ones, and then the integration will show the others. Okay, so let's have a look at question 1. Oops. Okay, so here we go. We should be happy with this one. So it's an 8-mark question. Okay, so the curve C has equation 3y e to the minus 2x equals 4x squared plus y squared plus 2. Find dy by dx. Okay, so the first things I notice is 3y e to the minus 2x. What is this? Product, yeah. We have two functions multiplied by each other. Okay, so this is going to be a product. So we're going to have v u. Okay, now the rest of the equation seems to all be okay, doesn't it? Okay, so product rule is v du plus u dv. Okay, so what is v? 3y. And what is the differential of e to the minus 2x? We're multiplying that by minus 2e to the minus 2x. Okay? Plus u, which is e to the minus 2x. And then the differential of v, what's the differential of 3y? 3 dy dx. Okay, and then we can simplify that in a minute, but at least we've done the left-hand side. And then we have 4x squared, which differentiates to 8x. Y squared differentiates to 2y dy by dx, and then 2 differentiates to 0. Okay, so now what I'm going to do is I'm just going to simplify the left-hand side a moment. So 3 times minus 2, this is going to give me minus 6y e to the minus 2x plus 3e to the minus 2x dy by dx equals 8x plus 2y dy by dx. However, we just want dy by dx on its own. So I'm going to move everything with a dy by dx on one side, and then everything else I'm going to move onto the other side. So which way round shall we do it? What would you prefer to do? Yeah, so minus 2y from both sides. Okay, so I'm going to have dy by dx brackets 3e minus 2x minus 2y equals 8x plus 6y e to the minus 2x. And all I've done in this step is move this to this hand side and then just factored out dy by dx. Okay? So now we're going to divide both sides by the bracket. So I'm going to have dy by dx equals 8x plus 6y e to the minus 2x all over 3e to the minus 2x minus 2y. So now we've found dy by dx by dividing this on both sides. So now, that was part A, nice easy 5 marks. It says point P on C has coordinates 0, 2. So the point P on C has coordinates 0, 2. Find the equation of the normal to C at P. Well, for the equation of a straight line, we need a gradient and we need a coordinate. What do we have so far? We have a coordinate 0, 2. If I substitute 0 and 2 into here, I'm going to have the gradient of the tangent. So let's find the gradient of the tangent first. So the tangent gradient is done by 8 lots of 0 plus 6 lots of 2 e to the minus 2 lots of 0 divided by 3 e to the minus 2 lots of 0 minus 2 lots of 2. And just to clarify, my x coordinate is 0, so everywhere there's an x I've substituted in 0, and my y coordinate is 2, so everywhere there's a y I've substituted in 2. Okay, I'm going to put this into my calculator exactly how this looks. And then my gradient of my tangent is minus 12. So that means my gradient of the normal is the negative reciprocal, which is positive 1 over 12. So now, y equals mx plus c. I'm going to have 2 equals 1 over 12 lots of 0 plus c. So c equals 2. Therefore, y equals 1 over 12 plus 2. Sorry, I forgot the x. 1 over 12x plus 2. And then we have 3 marks. Nice and easy 8-mark question. So, as you can see, that question before was implicit differentiation. This question now is our simple rates of change. Okay, so the simpler differential equations one. So this is our next scale. So, figure 1 shows... I don't know how to say that word. However, it's a hemisphere. Hemispherical. Hemispherical. I mean, I know it's a hemisphere. Hemispherical bowl. And it just looks ridiculous. Right, anyway. Water is flowing into the bowl at a constant rate of 180 centimetres cubed per second. So what does that mean? That means... dv dt, our rate of our volume, is 180. So with these questions, we always write down whatever we know. Okay, we can read the whole question first and then come back to this. However, I don't know which way is the right way. I just know that as soon as I see it, I'm just going to write it down that I know it. And when the height of the water is h centimetres, the volume of the water is given by this. So this is what our volume is given. Okay, find the rate of change of the height of the water. Okay, so what do we want now? Yeah, we want dH over dt. Because it wants the rate of change of height. Okay, and h stands for height. When h is 15. Okay, so I want dH dt. So dH dt can be formulated by, what do I need? What do I already have here? V. I want H and T, so V is the uncommon one, right? So I'm going to need dH dV multiplied by dV dt. This is what I need, okay? This is what's happening in our lives. And then our V's can cancel, and then we have dH dt, right? Okay. So if I have V here, I know what V is. If I can differentiate V with respect to H, and then I can flip it to get my dH dV, can't I? This is all manipulated now. I'm just thinking, what have I got? What can I do? I've worked out the equation. Right, so dV dH. So let's differentiate this. However, before I differentiate this, what do you think is probably the best thing? It's probably to expand the bracket. Okay, so let's expand the bracket first. Let's rewrite V. V equals 30 pi h squared minus a third pi h cubed. This is expanding this bracket here. I'm now going to differentiate V with respect to H. Remember, if we ever differentiate V with respect to H, it always has to be V equals with something with H in. So if I differentiate this now, I get H squared differentiated is 2H. So I'm going to multiply 30 pi by 2H, which is 60 pi H. Remember, the 30 pi is just a constant, yeah? And then H cubed differentiated is minus pi H squared. Because we're going to bring 3 down. A third times 3 is 1. So minus pi H squared. I've now differentiated V with respect to H. So remember, my formula to find the height when H is 15, so dH dt equals dH dv, what do I have? dv dh. How am I going to find dH dv? 1 over 60 pi h minus pi h squared is going to give me dH dv times that by dv dt. They gave us that in the question. That is 180. They've also told us in the question that h is 15. So what I'm going to do now is everywhere there's a h, what am I going to substitute in? 15. So, there we go. I'm now going to solve this in my calculator, and it just wants two significant figures. So I'm literally just going to write into my calculator 180 over 60 pi lots of 15 minus pi lots of 15 squared. And this is going to give me 0.085. Is this two significant figures? Yeah, because it's 0.0848 to two significant figures. So the unit, because we're just dealing with height, is centimetres per second, you know? Okay, so now what we're going to do is we're going to bisect this, because I know that some of us need just to... We've gone through it. Now let's talk through this. Okay. Ask questions as we go along. Okay, question time. So, what I did here was, I need dH dv. However, when I have, because I had v equals, I could only differentiate this. So I know, okay, that dH dv equals 1 divided by dv dh. Okay? So this is why, once I got my differential here, I put 1 over, so I got the dH dv. So I just did the reciprocal. And that's why.
We also put the steps, like the step 1 to just not actually frame it like that.
Okay, so step 1, are we ready? Right, so let's do this together. Right, step 1, I read the question, and it said the water is flowing into the bowl. Okay, if water's flowing into a bowl, I'm talking about volume. So step 1, I wrote this equation. I turned the words from the question into this. Another way to know if it's volume or not, if this is centimetres cubed. If it's cubed, it's volume. If it's squared, it's area. If it's just centimetres, it's length. Okay? So this is how I know that this was volume. This is how I knew that this was dv dt. And remember, if we're looking at rate over time, it's always over dt. Because what we're seeing is how rate increases over time, yeah? Then the next step I did was, when the height of the water was h centimetres, the volume was given to me by this. So I looked at this equation here, and this gave me the volume. And I was like, okay, so we've been given v, haven't we? Right? So I've been given v. So I just writ that here now and expanded it to make my life easier. So I've gone from here to here, I just expanded it. Okay? I might not have done this in this exact order, but this is where then it all came together. Then it wants us to find the rate of change of height in centimetres. So this is dH dt. That's what it wants us. It wants us to have dH dt. So that was like step 3. It wants dH dt, the height. Or you could put dl dt, the length, you know, because it's in centimetres. So then what I did was, I know, now this is the part which some people struggle with, but this is the easiest. So I want dH dt. That's what I want. So this equals something, because I know I need to calculate this, right? So this is step 4 now, is I want dH dt. What have I been given in the question? I've been given dv dt. Yeah? So I've been given dv dt. What do I need to multiply dv dt by to get dH dt? I'm making this up now. What do I need to multiply this by to get dH dt? I need to multiply this by dh dv. This now tells me that I will then be cancelling my dv's, yeah? Because I know if I cancel them, okay? So now I think to myself, right, what do I have? What do I want? Okay, I want dh dt, that's a given. It told us in the question I want that. dv dt, do I have it? Yes, it's here, it's 180. dh dv, do I have that? No, I do not have that yet. However, step 5. So step 5 is figuring out, I now need to find dh dv. Okay, so step 5, I need to find dh dv. However, I don't have a formula that says h equals with v's in, do I? I have a formula that says v equals with h in. So now step 5 is I now need to know that I need to find dh dv. However, I know because I've got v equals, I can find dv dh, and I know dh dv is 1 over this. So I differentiate this. So now we're at step 6 here. Step 6 is I differentiate it. Okay? Do I now have dh dv? Yes. So now I use the formula. So now step 7. I mean, I probably wouldn't write all these steps up, but this is just showing you my working. So dh dt equals, I've written it the other way around, but it's okay. dh dv, here, 1 over dv dh is dh dv. So this is this. Where it says 15, it's supposed to say h. However, the reason why it says 15 is because in the question it says h equals 15. So I just substituted earlier. But if you rewind back in the video, it did say h. I've just deleted it. And then I need to multiply this by my dv dt. Okay? So I literally put it into the calculator because it wants two significant figures and not an exact form. So the 8th step is putting it into the calculator exactly how it looks. And then the 9th step is rounding to two significant figures, because in the calculator it was 0.0848 something something. Okay, so the last step was then rounded to two significant figures. Whilst doing all this, and then once I finish this, I just double check the question. So this is how I did this question step by step. You just have to think about what you have, what you want, how you can manipulate math to help you. You guys are awesome. Question 5. Okay, this is definitely one that we can do. We can definitely, sorry, not question 5, page 5, question 3. Are these questions in the wrong order? Did one of them say question 4 a minute ago? Yeah. They're all in the wrong order. Okay, that's fine. However, we can do this with the knowledge we have right now. So let's do this one together then. Okay, so the curve C satisfies this equation. Straight away, I know that this is implicit differentiation. Okay, because it contains y's in the equation. It's parametric if we have the t's. So the point P cuts the coordinates out here, lies on C. The tangent to C at P cuts the x-axis at the point A and cuts the y-axis at the point B. Given that O is the origin, find the exact area of the triangle OAB, given your answer in its simplest form. Amazing. So, probably should find the equation of the line, equation of the tangent, find out where it cuts the x-axis and the y-axis, and then we're then going to be able to find the area of the triangle OAB. Okay, so I'll draw a picture after. So we're going to need to start. How do we find an equation of a line? What do we need? We need a gradient and a coordinate. What have we been given? A coordinate. How can we find a gradient? Yeah, we need to differentiate the equation. So let's start. So x and e, what do we notice? This is a product because e to the power and it contains a function. If it was just e to the power of 5 and it's just a number, this is not a product rule because e to the power of 5 is a constant. So we're going to have v du plus u dv. So v is x. The differential of u is e to the 5 minus 2y multiplied by the differential of the bracket. If I differentiate 5 minus 2y, what do I get? Yes, minus 2 dy dx. Plus u, which is e to the 5 minus 2y, multiplied by the differential of v. V is x, so the differential of v is in fact 1. Minus y differentiated is? 1 dy dx. This equals 0. Okay, so now I need to simplify this. So I am going to have minus 2xe 5 minus 2y dy by dx plus e to the 5 minus 2y minus dy by dx equals 0. I'm going to move everything to the right hand side to get rid of the negatives. So I'm going to get e to the 5 minus 2y equals dy by dx plus 2x e 5 minus 2y dy by dx. I now need to factorise out dy by dx. Dy by dx. 1 second. Minus where?
The e power of 5 minus 2y, it's minus.
Is a minus in the question? No.
Minus y. That's why.
Minus. Yeah, I've put the minus here, yeah? I've moved this onto the other side. You've done it a different way, that's fine. We can cancel all your negatives. If you have a look at yours, all of yours contain a negative. You can divide all yours by minus 1. Yeah, it's the same, just slightly different. So we're going to have 1 plus 2x e 5 minus 2y. This is e to the 5 minus 2y. So now, dy by dx equals e to the 5 minus 2y all over 1 plus 2x e 5 minus 2y. So you should have the same as me now. Perfect. Okay. Brilliant. So now that we've got this, let's have a look at what we need to do. So this is our gradient. We want the gradient of the tangent, so we don't need to do any negative reciprocals or anything like this. We literally just need to substitute in these values. Okay? So everywhere there's an x, what are we going to substitute in? 2e to the minus 1. Everywhere there's a y, what we're going to substitute in? 2. Okay, so let's do this. So the gradient of the tangent equals e 5 minus 2 lots of y, which is 2. Okay. Now when I'm doing these types of questions, I'm not going to put anything into my calculator yet. I'm just going to try and do this. My numerator now, 5 minus 4 is 1. So this just becomes e. Okay, remember this. Sometimes people put it into the calculator. You're going to get some decimals. We don't want any of that yet. We need everything exact. Okay, because it wants the exact area of the triangle. Now, we have 1 plus 2 lots of x, which is 2e to the minus 1, times by e to the power of, now we already know 5 minus 2y, when we substitute in 2, what do we get? 1. So we can already do this as e to the 1. Okay, now you can see how nice and easy this has made it, because e to the minus 1 times e to the 1 is e to the 0, and e to the 0 is 1. So that means you've got 2 times 2 times 1, which is 4. So this becomes 4, so 1 plus 4 is 5. So there we have our gradient. And what we've done here is we've done exact values the whole way. So we know that this actually calculates to, this calculates to 4. Okay, and this is why sometimes using a calculator doesn't help us. We need to look at what's happening, yeah, be able to manipulate this. Okay, so now we have our gradient. So now we can write our equation of a straight line. So y equals our gradient x plus c. Okay, now I'm going to have to substitute in our values. So 2 equals e over 5 times 2e to the minus 1 plus c. Okay, so what we're going to have here is 2 equals, remember 2e to the minus 1 is actually this, e over 5 times 2 over e. Our e's are going to cancel, plus c. So we're going to get 2 equals 2/5 plus c. So 2 minus 2/5 plus c, equals c. This is 8/5. Okay, so it's 8/5 right here. So our equation of a straight line is y equals our gradient e over 5x plus 8 over 5. Okay, so now we need to find where it crosses the x and the y-axis because it wants the points A and the points B. So where does it cross the x-axis? Crosses the x-axis where y equals 0, absolutely. So if we want to find where it crosses the x-axis, it's when y equals 0. So we're going to get 0 equals e over 5, x plus 8 over 5. Okay, rearrange this, we're going to get minus 8 equals e to the x. So x equals negative e over 8. Someone just checked my maths that I did in my head. Yeah, perfect. Right, so we know then that the first coordinate is minus e over 8, 0. Okay, and then I have divided by 8. What are you seeing? Yes, no, it's minus 8 over e. I told someone to check my maths. Right, so minus 8 over e. I've tried to do it in my head quickly. Okay, and then how are we going to find the y-axis? This is when x equals 0. So we're going to have y equals e over 5 lots of 0 plus 8 over 5. So this is just going to give us 8 over 5. Okay, so now I have 0, 8 over 5. So if I was to draw this, okay, remember this is our point A, B. So if I was to sketch this as an axis, x, y, can someone just put minus 8 over e into the calculator? Is it negative 3 point something, I reckon? It's about negative 4, realistically. Pardon? Negative 2.9, brilliant. So this is the point, minus 8 over e 0. This is the point, 0, 8 over 5. If I'm now going to find the area of this, AOB, it's really simple, isn't it? What am I going to do? Base times height divided by 2. Our height is 8 over 5. Our base is 8 over e. Please do not leave this as a negative. We're thinking about the length here. So base times height, 8 over 5 times 8 over e, and then we're going to divide that by 2. It's going to give me my area of the triangle, isn't it? AOB. So I'm going to get 64 over 5e. If I divide that by 2, that's the same as times and by a half, which is 32 over 5e units squared.
Did you just
Okay.
substitute zeros?
So once I found the equation of the line, I needed to find the points A and B where it cut the x-axis and y-axis. So when it cuts the x-axis, y is 0. So I substituted y as 0 to find the coordinate of A. Then where it cuts the y-axis, x is 0. Yeah, into the equation of the line. And then equation of the triangle is this. Okay, because remember the question says, given that the O is the origin, find the exact area of the triangle, given your answer in its simplest form. So right now we cannot simplify 32 over 5e. If you'd have written 64 over 5e and then written divided by 2, you still haven't finished it all off yet, have you? Okay? If you'd have written 64 over 10e, you could have simplified that more. You would have lost out on a mark. Seems a bit silly. So yeah, well done everyone. Question 6. So, the curve shows in figure 3 has parametric equations. It meets the x-axis at the origin and at the points A and B is shown in the figure. Write down the coordinates of A and B. So, it wants us to write down the coordinates of A and B. First of all, really, let's go back to basics. What do we know about the coordinates A and B? They are on the x-axis. What do we know? If something is on the x-axis, what does that mean? Y equals 0. Do we have an equation anywhere that says y equals? We do. So therefore, instead of y equals 9 sine of 9t, we have 0 equals 9 sine of, sorry, that's a 2, of 2t. So now we can solve this to find out what t equals. And once we know what t equals, we can then substitute that into here to find what x equals. It's like really super simple, okay? Now for us, this basically means straight away that sine of 2t equals 0, okay? Now this is between 0 and 2 pi. So if I was to draw this between 0 and 2 pi, now remember, if it's 2t, what's happened to the graph? It's expanded. Because so for example, the normal sine graph would look like this. Sorry, no, it's like, I don't know what the word is, not expanded. It's like halved. Yeah, is it contracted? So it's now going to look like this. Okay? So what are our t coordinates now? Okay, remember this is t, this is y. So we know that this is pi over 2. Pi, don't forget there was that 0, and also this is 3 pi over 2. And this is 2 pi. Okay? So this is what our t values are. Now, when I substitute this into, what do we have? Cos, so x equals 3 cos of t. So for each value of t, I'm going to find an x value. So x equals, so let me substitute in 3 cos of 0. So what is 3 cos 0? What is that? Deja vu. I'm sure I've done this question with you recently.
Yes.
You just forgot. Did I record it? I have no idea. 3 cos.
Because cos t.
Cos of 0 is 1, so that's 3. Okay, so what is 3 cos of pi over 2? 0. What is 3 cos of pi?
-3.
Okay, what is 3 cos of 3 pi over 2?
0.
And what is 3 cos of 2 pi?
3.
So you can see here, even though 0 is repeated, it doesn't matter. X is 3, 0, minus 3. So that means my coordinates of A, we can see A is on the negative side, is minus 3, 0. And my coordinates of B are 3, 0. So there we have A and B, because the coordinates of the origin were also passed through 0, 0. Really nice and easy. Now, I know that was only 2 marks. I don't really know how to do it a quicker way. Obviously, if I wasn't explaining every detail, it could be quicker. Right then. Find the values of t at which the curve passes through the origin. Okay, well that's nice because we've just worked that out, haven't we? What values of t does the curve pass through the origin? Well, we just worked out it passes through x is 0 when t is pi over 2 and when t is 3 pi over 2 because we've just worked this all out. So actually all that hard work has enabled us to answer questions 1 and questions 2. So t equals pi over 2 and 3 pi over 2. Okay. It then says, find an expression for dy by dx in terms of t and then hence find the gradient. So if x equals 3 cos t and y equals 9 sine of 2t. Okay, how are we going to find dy by dx? We're going to find dy, we're going to differentiate y with respect to t and multiply it by the differential of t with respect to x. However, we don't have that, so we're going to differentiate x with respect to t and then do the reciprocal, right? So, dx by dt is 3 cos t differentiated. Remember, it's sine, cos, minus cos. So cos differentiates to minus sine. So we're going to have minus, so that's minus 3 sine t. So that means that dt by dx is 1 over minus 3 sine t, which, by the way, we would just say is minus 1 over 3 sine t, okay? Now, differential of y with respect to t. Sine differentiates to cos, so we're going to get 9 cos 2t, and now we need to multiply this by the differential of the bracket. What's the differential of 2t? 2. So this is, in fact, 18 cos 2t. Now, to find dy by dx, I'm going to multiply dy by dt by dt by dx. So that means dy by dx equals 18 cos 2t times negative 1 over 3 sine t. So dy by dx equals 18 divided by 3 is going to be negative 6 cos 2t over sine t. Now hold up. Some of you are probably thinking, cos over sine, I know, that's cot. No, not in this case, because we have 2t here and we have a t here. We cannot simplify this because what's inside the bracket is not the same. So this is simplified form. Then it says when t equals pi over 6. So now, everywhere there's a t, what am I going to substitute in? Pi over 6. There's 2 lots of pi over 6 over sine of pi over 6. I'm literally going to put this strictly into my calculator. So, what do I get? Okay, which gives me minus 6 is the answer. Anyone have anything different? Perfect. Well, that's lovely. It then says, show that the Cartesian equation for the curve can be written in this form. Okay, so wait there. So I'm going to write it over here. It wants it in the form y squared equals a x squared b minus x squared. And what do we have again? X equals 3 cos t, y equals 9 sine 2t. So now this has got nothing to do with differentiation. We're now going back to the previous chapter, aren't we? Okay. Oh, I know where we've done this question. We've done half of this question in the previous chapter. We just didn't do the differentiation part of this. This is exciting stuff. Right, so we should all be able to do this. So first of all, what does cos t equal? X over 3 is cos t. Right. Y over 9 equals sine 2t. Do we have a formula for sine 2t? What does sine 2t equal? 2 sine t cos t. Okay, we have cos t. Do we have cos t? Check. What do we need now? Sine t. What do we know that relates sine and cos? Cos squared. So we know that sine squared plus cos squared equals 1, right? So if we want sine, what do we know? That sine equals 1 minus cos squared. So sine squared equals 1 minus cos squared, doesn't it? So sine equals the square root of 1 minus cos squared. Everyone happy with that? So now I have y over 9 equals 2 lots of the square root of 1 minus, what is cos? X over 3 squared times cos x over 3. So from here, let's just multiply everything out for a second so we know where we are. So, y over 9 equals 2x over 3 root 1 minus x squared over 9. Okay, this is where we are. Now, let's multiply both sides by 9. So y equals 6x root 1 minus x squared over 9. However, in the question there's a y squared, right? So let's square everything. So if I square absolutely every term, I get y squared equals 36x squared, brackets 1 minus x squared over 9. However, guys, this is really important. Do you remember when we looked at manipulating here? Here they've given us an x squared. They haven't given us anything. They haven't done this. So how do I now manipulate this? What am I going to factorise out? A ninth, okay? So I go y squared equals 36x squared, lots of a ninth. Okay, so if I factorise out a ninth times what is 1? 9. Minus. And then a ninth times what is x squared over 9? X squared. So this is how we do that part, yeah? Then, the reason why I haven't multiplied this by this is so that we can see that this times this is 1, this times this is minus x squared over 9, because this is where people get the most problems. So therefore, y squared equals 36x squared times the ninth is 4x squared, brackets 9 minus x squared. And now we have it in that form, okay? Where we have ax squared, b minus x squared. It's just beautiful, really, isn't it? Yeah, okay? Right, how many marks was that? 12 mark question. Look at all that. It's wonderful. Well done.